Okay, I want to show you a little bit about laying out a part. Laying out a part means you're scribing lines on the surface of the part that you're going to machine to. You might be making an intersection that shows you where you're going to drill a hole, a line that you're going to machine a flat surface to, arcs, all kinds of different things you can do with layout. And typically we use a layout die for that. This is a Dychem steel blue. And if you take the cap off of this, remember to always put these caps back on because they dry out if you don't. And this brush has already dried out quite a bit. It's going to make it hard to get a good finish with this. But here's a part. If I was going to lay out just this corner of the part, I wouldn't paint the whole part. I'd just lay out the areas that I'm going to actually be using. It doesn't come off your clothes very well, so you want to try to avoid getting it on your clothes. With a stiff brush like this, sometimes I'll go at an angle to the lines I'm going to be drawing, or rather scribing, I should say. You want to get a thin surface, thin, even surface. This brush is really, really stiff, making it difficult. You don't want a thick surface because when you scribe these lines, scribing is the operation of scratching off this die. When you're scribing lines, you're not actually scribing the part. You're not trying to scratch the part, you're trying to just scratch off this die that you're putting on. If you put it on too thick, it'll flake off and you won't get a nice crisp line. This is a little challenging with this brush, but we're getting it. There's also a spray can you can use for spraying on die. That works. I actually prefer that. I usually don't use it in a teaching environment because sometimes it gets a lot of overspray. What you don't want to do is ever apply this dye on the surface plates here. These are precision surfaces. We don't want to get dye on them. So I'm going to go ahead and let that dry. In fact, while it's drying, I'll talk a little bit about surface plates maybe. I've got my hand on a granite surface plates. Surface plates are usually either cast iron or granite. If they're made out of cast iron, the cast iron usually has to be aged over time before it's machined, made flat. Whereas granite, it's been aged over millions of years, you don't have to do that. The other thing about cast iron is if you leave anything steel on a cast iron plate, even overnight, this will tend to rust itself right to the cast iron plate, whereas with a granite plate, you don't need to worry about that. These plates are used as a reference surface, a flat reference surface. They come in different grades. Let me see, a AA grade is a laboratory grade, and it's flat over the surface of the plate within 25 millionths. Whereas an A grade is an inspection grade, and that's flat to within 50 millionths of an inch. And a shot grade, which is probably like this, would be a B, a grade B, and it would be flat to within 100 millionths of an inch, which is still pretty flat. And if you ever have a choice of ordering between the two, I would recommend you get the granite plates. Some of them are just flat like this, some of them have a ledge. There's another plate right over here, and that has a ledge on it. Can be helpful for clamping things down if you need to. And there's a variety of things you can put on those ledges. Let's see, some of the other things I'm going to show you here are for laying out. Let's start with what's called semi-precision layout. This is a combination set. Combination set right here. Combination set's made up of four main components. You've got the steel rule, you've got the square head, you've got the center head, and the protractor head. Let's take a look at that for a second. Take the steel rule out. First thing you want to notice about the steel rule is that it's got a groove right down the middle of one side. Very important to remember that. Take the square head out, and you see this little rod here on the end of this nut. If you look inside, if you could see inside, you'd see that there is a slot here, and in that slot you see coming off of that rod a little protrusion. It sticks out like that. That protrusion goes right in that groove. So when you put it in, square head or any of these heads, you want to make sure that the groove is lined up with that piece that's sticking out of that rod. If you don't do it, it won't go. I've seen students hammering away to get that in there, and I suppose it goes eventually, but it sure is a lot easier just to line it up and slide it in. Once it's in there, you need to tighten that nut, and it draws that steel rule right up against the slot. And now you have a right angle here, 90-degree angle, and a 45-degree angle here. Those angles can be used for checking the squareness of a part. So if you have a part, I'm going to check and see how square it is. Check like that. It can also be used for laying out lines, like I'm going to show you in a minute. Put the square head on here. We can take a scriber and scribe lines at a 90 degree, or with the square head you've also got a 45 degree option here. Another thing you'll notice about the square head, usually they have a little bubble level on them as well. You can put that on, you can check things for level. And in addition to the square head, we've got, let's see, let's look at the center head next. Center head, it's got the slot, it's got that same piece with that same protrusion. Hook in the slot, find where it protrudes, line up the groove. And slide that in. You just loosen the nut, push in on it a little bit, and you should be able to get that right in there. Should be able to get that right in there. It's actually twisted and stuck in that orientation. I think I got it. Just as easy. Just as easy as anything. There, it's starting to go. There it goes. So now we can go ahead and tighten up that nut on there. The center head is used for locating the center of round stock. And here I've got a piece of, it's not really a round stock, but it should give you the idea anyway. Put that round stock in there. I can go ahead and take a scriber, which is just a sharp point. Scribe it here, I can scribe a line and rotate it 90 degrees. Scribe another line, and hopefully the intersection of those two lines is the center of that part. You can also take and rotate a 180 from your first line, scribe again, and then if you end up with two lines, you know that the actual center is between those two lines. That's what the center head is used for. And it can also bisect a 90 degree angle, so if you wanted to scribe a line on a 90 degree, you go like that, and put in a 45 degree angle there. Not used as much for that, something else you can do with it. Let's take that off and look at the protractor head. So a little bit of a puzzle to get this thing to go back together, so I'm kind of taking note of how it looks before I do it. Protractor head has that same slot, same part, rod, slide it in, tighten the nut, and the protractor head is used for measuring or laying out angles. And you see we have a scale here, and the scale goes from 0 to 90 this way and 0 to 90 in that direction. And we have a little mark up here indicating how far we've gone from 0. And on the back of this, we have two lock screws. Thumb screws here. Actually, I guess they're nuts on this. We tighten this little nut up, and that locks it at that angle. If I loosen it, now I go ahead and measure any variety of angles here. So we certainly could measure a 90 degree angle. If I wanted to set this at a 30 degree angle, it's either going to be 30 or 70. If there's 70 degrees, 30 degrees off of 90, or I can go all the way to 30. Anyway, you can set your angles up on this. Once I've got that angle set up where I want it, I can lock it. And now I can lay out that angle on my part. For instance, if I want to scribe a line on this part, you see the die is dried now. I can hold my part there and scribe my line where it belongs. And the die helps that to show up. We're not trying to gouge the metal, we're just trying to scratch the die off. That's what the die is for. So there's the combination set. That also has a bubble level on it, so you can set up angles using that bubble level. Oops, loosen that nut there, pull the steel rule out, get this all put back in. Combination set. In addition to the combination set, we've also got the solid square here, also for 90 degree angles. And we can scribe. Scribers, talk a little bit more about scribers. Here's a scriber with a carbide point on it. It's very hard and wear resistant. I've made a lot of scribers over the years. This is just a scriber with a little piece of music wire sharpened up, shoved into a piece of wood, Tinker Toy piece of wood. That works really well as a scriber. You can buy them all different kinds of shapes and sizes. Let me show you another method of using your combination set with your square head here. If you wanted to put a line parallel to this edge, a ½ inch away, I've set this up so it protrudes a ½ inch. I can just take my combination set and my scriber, and now I can scribe that line and make that parallel to that edge. In fact, say I wanted to make the a ½ inch radius here. take and go a ½ inch from both edges at that intersection. If I wanted to scribe an arc now, right here, I could take a set of dividers. I'll show you what dividers look like. This is a set of dividers. You might think of them as like a compass. The dividers can be adjusted. They're spring dividers. There's 2 sharp points. I can adjust this to that ½ inch using a steel rule, or I can just put the center of these dividers right at that point and adjust it so it's right tangent with that edge, and then go ahead and scribe, just lightly scribe, try to get so you can see here, just lightly scribe that arc. There, I've just scribed a ½ inch radius. I can take that over to the bandsaw now, saw that off, file it up to the actual size. That's one of the things you use dividers for. Another thing you use dividers for is actually dividing. That's where they get their names. Say I want to divide this line up into 3 equal components. Just guesstimate what a third would be, and then put it on one end and scribe a line, put it on the other end, scribe a line, put it on that intersection, scribe the line. We can see that we didn't come out quite right. So what we want to do is increase that amount by about a third, and you just repeat that till you get it to come out right. And by the time you're all done, you divided up a line very accurately without any math at all. I overshot that time, but you get the idea. That's dividing. You can also use it on bowl circles. If you have a circle, you just go right around and divide it up. Dividers are used that way a lot. This isn't so much what dividers are used for. Sometimes I use them to describe a parallel line like that as well. And speaking of that, let me show you the tool you're really supposed to use for that. It's called a set of hermaphrodite calipers. These are hermaphrodite calipers. They're hermaphrodite because hermaphrodite means both male and female. These have 2 different kinds of tips on them. It's really get the name. You can adjust this. Bring that up to your steel rule, adjust it to whatever you want for a distance, tighten it up, and now you can go ahead and scribe that parallel line. It just happens to be exactly where I had it before, that parallel line. Another thing you can use these for is for finding the center of a piece of round stock. I showed you before with the center head. If I wanted to find the center of this, I can go ahead and adjust it, make a guess, scribe a line, and right in between those 2 lines is the center. Just repeat that 90 degrees. Oops, I want to keep one end still. And right in between there is the center of that part. So that's another use for hermaphrodite calipers. In addition to hermaphrodite calipers, actually let me show you the protractor plate. The protractor plate is used very much the same way that the protractor head and the combination set is. You just go ahead and set your angle right there, and now you can scribe a line at that center. And these are only good to a degree. Protractor plate and the protractor head are both only good to within 1 degree of arc. This is a surface gauge I made when I was back in school, and all the parts are hardened and ground. And the idea of a surface gauge is there's a lot of things you can use a surface gauge for. For one thing, you've got a scriber on it. This is a scriber, and you can tighten that and adjust it in different places, lock it, and then you have a fine adjustment screw for changing the height. You can see that tip height is changing, and I can set that height up wherever I want. Let's say the center of that arc. And now I can go ahead and scribe a line using my surface plate. So my surface gauge goes on my surface plate. You can see I just slide along the surface plate and I get my parallel line scribed. Also notice what I'm doing here is I'm using an angle plate. This angle plate has a 90-degree angle to the surface plate. And if I try to scribe a line just holding this, it's going to probably move around and I'm going to end up with a wavy line. But the angle plate holds that nice and square to the surface plate and ensures that that line is the right height from the surface plate. So that's a surface gauge, one of the things you use a surface gauge for. Next I want to show you how to scribe a line in a similar manner using a vernier height gauge. Vernier height gauges we've talked about before, setting them. But just as a quick review, here's the base, here's the beam, which has the main scale on it, and then we have the whole vernier slide here with a scriber on the end of it. And if you lock the top portion of the slide, you have a fine adjustment screw for setting heights. And to set the height, you just find the 0 on the vernier scale, make it line up as close to the reading that you want. Let's say we wanted 1 1/8. I would go ahead and slide the 0 on the vernier to 1.1 and then 25 thousandths. Lock the top and use a fine adjustment screw. You're probably zoomed in, so I'm going to have to actually do this for reading. Use the fine adjustment screw here to set that on. I'm going to show a little bit. 1 1/8. And then I can lock that. I've set that to 1 1/8. Now using the scriber point, I can go ahead and scribe my line at 1 1/8 inches. Again, I'm just lightly dragging that sharp corner along, taking off the die from the part. And if I had to scribe another line at a right angle, maybe I'm going to use the intersection of those two lines to drill a hole. That's using the vernier height gauge. One thing I should mention about that, before you actually start using the vernier height gauge that way, you want to take and make sure everything is nice and clean, the plate, height gauge, and calibrate it. Slide it all the way down, and then I always talk to pull it sideways. If there's any dust in there, it'll roll out. Lock it, and then take your reading. Make sure the 0 on the main scale lines up with the 0 on the vernier. If it doesn't, like say I read 3 thousandths right there, I just add 3 thousandths to all my readings. Let me know, and then maybe I can take the time to calibrate the actual instrument. Another height gauge is called a digital height gauge. Calibrated the same way. Turn that on. This height gauge usually takes a second or two, it usually takes a couple minutes to really warm up good. But do the same thing, make sure everything's clean, bring it down so the scriber point is up against the surface plate, and then you can 0 this readout, and that reads out directly your height. This little LCD display. And you can use that for scribing lines, you can use it for measuring heights. This has got a pretty good range on it, so if I wanted to measure the length of this part, which is probably longer than what your digital calipers will read, just come right over and take the reading directly off the scale. So those are 2 height gauges. When you're using height gauges to scribe lines, that's called precision layout, as opposed to semi-precision layout when you're using your steel rules and your combination sets. So that's some of the ways you're going to lay out lines. I have here what's called a prick punch. A prick punch has an included point angle of 30 degrees. And that's used for locating the intersection of 2 lines. I'll show you right now. 2 of those lines that we scribed on here. I'm just going to go ahead and hold this at about a 45-degree angle from the surface of the plate. And you can feel it drop into that intersection of the die. If you're very careful, you can feel that drop right in. Stand it up and just give it a little tap. Usually it's a little smaller hammer than this, but just a very, very light tap. That's called prick punching. I don't know if you can see that little prick punch mark there or not. But after that's been prick punched, you look at it very closely, sometimes with a magnifying glass. If it's not right where it wants to be, say, if I look at that, it looks a little high, you can take and put your prick punch back in the mark and lean it away from the way you want to go, and just give a little bit of a tap. And you can push that hole around on the surface of the part. Once you get it where you want it, that looks pretty good right there. You can use that now to scribe an arc. I'm talking about using the dividers to scribe an arc. That'll keep that point right in there, so you can scribe an arc out nicely. Or if you're going to drill a hole there, you're probably going to want to center punch it next. Now, prick punching is a layout operation. Center punching is not a layout operation. That takes the laid out prick punch hole and it enlarges it. A center punch has a 90-degree included point angle on it. That's going to enlarge that prick punch. Once we get the prick punch where we want it, I'm going to go ahead and center punch it. When I do this, I like to be over the corner of a bench where the leg is, so it's nice and solid. You do not want to do this on a surface plate. Very bad for those surface plates. So I've just prick punched that hole. If I was going to drill that hole in a drill press now, I could take it over and I could feel that prick punch mark with a center drill, locate my spindle axis over the hole. Now, in this course where you're making a steam engine, I don't anticipate you're going to be using the center punch probably at all. All you need to do is use your edge finder and locate your spindle axis over where you want it to be. But I still want to show you how to do that layout in case you ever have to do it. So that's prick punching. and center punching. Let me show you one more center punch here. I have another center punch. This is called an automatic center punch. It's spring loaded. And once you get your prick punch mark, you can go into that prick punch mark and just push down. And listen, you'll hear it. Prick punches it, excuse me, center punches it without a hammer. It loads the spring up and then it gets kicked off to the side, and a little hammer inside there, a little slide, pushes down on it. Usually you only have to do that once on a part. This is a set of gauge blocks. Gauge blocks are precision blocks. They've been machined to length. This is a 4-inch gauge blocks. Between here and here it's 4 inches, quite precisely. There are different grades of gauge blocks, just like there are surface plates as well. If you notice here, the precision surfaces have been ground and lapped. Very, very smooth and shiny, as opposed to the surfaces that aren't locating surfaces. And gauge blocks come in all these different heights. This is a pretty small set actually, but if you wanted to add up to 1.203, you could take a 1-inch, a 1/20, and a 1-inch and 3/10,000ths, and you can stack them up to get you different heights. So by doing a little bit of math, you can get all these various heights. Kind of a neat thing about gauge blocks, if they're in good condition, I can show you something. The human wrist has not a lot of oil on it, so it's a good place to wipe them if you don't have the special rag. That doesn't look real good. I'm going to take 2 of these surfaces and show you how to ring them together. If you take 2 gauge blocks, make sure they're very clean, push them together and slide those surfaces at the same time. What you're doing, may or may not, I'll try this one. There we go. You can see right now that these 2 blocks are sticking together. That's because all the air between them has been displaced, and atmospheric pressure is holding them together. They're not at all magnetic. See, it's a pretty good amount. You can see right now that there are no way are they magnetic. Once you've done that, you're sure that there's no dust or anything in between there. So if you ring up a stack of gauge blocks, you can be pretty sure that that height is accurate. So to take that stack, what are we going to do with that height? Well, usually you're making a comparison with them. There's a number of things you use with gauge blocks. Let me show you one where we're checking a part. So I'm removing my scriber from my surface gauge, replacing it with this dial test indicator. And the dial test indicator goes right in the hole the scriber was in, just like that. You can see the dial test indicator as the little finger on the end here is depressed. It measures out in thousandths of an inch. They also come in 10,000ths of an inch if you want to get closer than that. And what I've done here is I've taken a set of gauge blocks. I want to check to see if this part is 1 3/8 high, 1.375. So I've taken a 1-inch gauge block, and in order to get to 375, some sets would have 375 gauge block there, but this one doesn't. I've taken a 170, a 105, and a 200, or excuse me, 170, 105, and 100 gauge block. You ring all those together, and we end up with our 1 3/8 height. The fewer blocks you use, the better. Now, if I take and put this indicator, rig this indicator up so it's right on the top, gauge blocks here. Try that again. I have a fine adjustment screw on my surface gauge. Now I can go ahead and zero my indicator. Rotate the bezel until the indicator reads 0. In fact, I'm going to just use the fine adjustment screw to bring this into adjustment. I'm trying to stay out of the way here, not bump it. There, that reads 0 right there. So now I can compare my part rather, to that height. Take my part in here and I can check, and I can see that my part is 8 thousandths less than that. So if I was shooting for 1 375, then hopefully I had an 8 thousandths tolerance, otherwise the part would be too small. So that's a very common way of using gauge blocks in an indicator, is making those comparisons there to check to see if it's within size. Another way of using gauge blocks is with a sine bar. Sine bar is probably the most accurate way we have of setting up angles in the shop. Sine bar has 2 rolls of equal diameter. There's 2 cylindrical rolls here that are spaced apart on its center, usually either 5 or 10 inches. some set amount, some set known amount. And this is always the hypotenuse in a right triangle. This is a 5-inch sine bar. If I wanted to set up this to a specific angle, you just calculate the height of gauge blocks you need in order to achieve this angle here. So if I set my gauge blocks in here, I've set that up to a certain height. The sine of this angle is equal to the height of the gauge blocks over this hypotenuse, which is 5. And if you want to measure an actual angle, I'll show you that. Alright, I have the sine bar set up. This is one way of using a sine bar. I want to determine what the angle is of this part between this surface and that surface. And if you notice, what I have here is, if you look at this as one line, this is another line, this is an angle intersecting those two parallel lines. We have two parallel lines cut by a transversal, opposite interior angles. Opposite angles or interior angles are equal. Excuse me. Oops, that's tipped a little bit. You probably didn't realize you'd be using that stuff you learned back in geometry, but that's one of the ways we use a sine bar to determine this angle. And what we do is we use the indicator, we adjust that angle until the indicator reads 0 the whole length. When that reads 0 on both ends of that part, we know that this surface is parallel with that surface. And I'm going to show you another little tool here. This is called an adjustable parallel. This adjustable parallel has two sliding parts, and you can see that this distance gets greater as you slide it up on that wedge there. Just a little dovetail, and it will clamp in place. And that's a good way of quickly adjusting a height here. Do this without everything toppling over. Put that on top of one of my gauge blocks. Make sure my part is straight. And if I put my indicator on my part, you can see that I can adjust it, go back and forth, and I can see that that is not touching right here. As I go, this is going clockwise, and it's going counterclockwise. So I'm going to have to change the height of that part a little bit. You just keep adjusting the adjustable parallel until the indicator reads 0. Oh, that was pretty close. It reads 0 the whole length of the part. When it reads 0 the whole length of the part, just take the adjustable parallel, measure it with a micrometer, then replace it with a gauge block. Double check with the indicator. If it reads 0 all the way across, you found that height within 1/10,000th of an inch in order to establish that angle. And it's a very accurate way of measuring an angle using a sine bar. Of course, you could lay out an angle that way too if you wanted to. You could set up the angle like it is here, part against it, and go ahead and describe your line. So that's using a sine bar, surface gauge, and indicator with gauge blocks. Here's another little sine bar. It's not as precision as the other sine bar I just showed you, but it's just a little CNC project. And this fits nicely right inside of a milling machine vise. Imagine this is up against a solid job. You just go ahead and set that with either a gauge block or an adjustable parallel, and then you can go ahead and hold the part at an angle in your vise. It works pretty nice. That's a 3-inch sine bar. Here's another little 2.5-inch sine bar. It can also be used. You can see sine bars come in a variety of sizes. They also come in entire plates, big wide sine plates. So that concludes our unit on layout.